So thank you very much for choosing track one, with my incredibly wordy title that I should have probably reworded. This is evolving the use of your SIEM to hunt and adapt through OODA. I'm going to talk about what that is. My name's Harry McLaren. I'm a managing consultant at ECS Security. I'm an alumnus of Napier University, co-leader of Cyber Scotland Connect, and also the Splunk user group Edinburgh leader as well. You can find me on Twitter, certs, because it wouldn't be an interest slide without them. My employer, we build and run SOCs throughout the country, and we build and run SIEMs throughout the country as well. So not really going to talk about them, but just so you know who we are. So what I'm going to go through will last about 45 minutes. I'll leave some time for questions and leave some time for me to overrun, because I've changed half this deck in the last 24 hours, which is a terrible idea and you should never, ever do. But it couldn't be helped because I couldn't get a bug out of my head about some of the content. So we're going to talk about a problem that I think is very prevalent throughout our industry. Talk about some foundational knowledge, so those of you that perhaps are not as aware of what SOCs or SIEMs are, so everyone's hopefully on the same page. Going to talk a little bit about what I see as some ineffectiveness within both SOC and SIEMs. Talk about OODA, which is a really old methodology essentially that comes from the Air Force in, I think it was World War I or II. They're going to go across into a bit of threat hunting and control gaps, and then finishing off by talking about how to change that platform quickly and at scale. Some terms of reference are on the same page. If I say the word SOC, I'm referring to a security operations center. This could be synonymous with a security guy, girl, team, individual, analyst. Doesn't necessarily need to be in its own organizational unit, but that's what I'm going to say. SIEM, Security Information and Event Management. This is a tool. It's usually built on a big data platform. It will usually involve some form of correlation or logic or rule engine or something along those lines. It's, within the context of this talk, going to be our primary tool to discuss hunting. Threat hunting or threat analysis. This is a proactive defensive action. So this is actually going to look for things in your environment that are at risk or causing you a problem or a threat actor. And this is trying to do something about it, as opposed to waiting until your tool tells you or until Twitter tells you that you have a problem. TTPs, tactics or tools, techniques and procedures. These are typically ways of describing activity or methods. So your threat actor will have TTPs, your defenders will have their own TTPs. And again, if I say it, that's what I'm referring to. So starting with a problem. Sorry if you can't read that. I wasn't expecting quite so much sunlight, having lived in Scotland for 10 years. This is a quote from Sean Riley, who's the Chief Science Officer, and he's a really interesting guy, and he's traveled the world, got far more experience than I do, so I thought, rather than come up with my own quotes, I'll just steal his. And I really like that last part, which is, as a business, so, as a line of business, whether you're a large global enterprise or bank, or whether you're a small to medium-sized business, how fundamentally do I detect that there are threats on my network trying to do something that's naughty? And the solution to that, or the solution that kind of we've been peddling for a very long time, I say I do work for a vendor fundamentally, so it is a we, is, well, you need a SOC. Everyone needs a SOC. You've got to have lots of screens, ideally as many big TVs on the wall with huge maps showing packets traveling from China or North Korea attacking your network. Looks great for the chief executive to walk in and go, look at all those attacks. We're aware of all of these attacks and we're safe, totally safe. Those maps rarely mean anything, obviously, but it's nice to look at something pretty on a wall. So I'm not going to be coming up to you and saying SOCs aren't the solution, but I'm going to say that they're not very effective. I'm going to get to that. So first of all, what's in a SOC? When I talk about a SOC capability or function, I'm talking about the kinds of things that a security team who are defenders are likely doing with their time. So on the kind of more normal BAU side, i.e. business as usual, we're talking about monitoring. So this is often monitoring other tooling. So for example, a firewall, a WAF, your identity solution, next-gen antivirus, all of these types of things. They see something they think is bad and they tell you about it. Someone's got to wait for that alert and hopefully do something else. Okay. Into the more detection space, this is when you start to get, detection analysis, sorry. This is where you start to correlate that data. So this is where you might start to build your own rules, your own logic. So rather than just waiting for your firewall to say bad is happening, it's saying, oh, but I'm seeing this, and this, and this, so bad is probably happening. Okay, so it's trying to bring a bit more intelligence to it, and, correlation or correlation rules or searches is a way we describe this. Hunting, which is like the focus fundamentally on what we're going to get to, this is proactive. So this is looking for things you don't know about. Because the interesting thing is when you write a rule, you've got to give it a pattern. You've got to give it a piece of logic. So, if I see 3 failed login attempts within 30 seconds, followed by a successful login attempt, am I being brute forced? It's a very rudimentary example, but it gives you an idea. Now, if I know what that looks like, I know what bad looks like, well, the tool, the magic computers that we all purchase, well, that can tell me when that happens. What it can't tell you is the tactics and techniques that you don't know are being used. So, fileless malware that executes in memory, for example, using PowerShell. Well, if I didn't know to look for it, why would I have a control or some logic that says, look for this type of activity? So this is what people would refer to as an unknown unknown. I don't know if it's there, and I don't know what to look for even if I did. Pretty difficult problem. This has started to be more recently called threat hunting, and it's a really valuable thing to do, which I'll get to later. Response and the automated and orchestration component of this. This is fundamentally when you know there's a problem, what do you do about it? There's an interesting argument around people that work in this space that say if you have no capability to respond to a problem, should you actually even bother looking for it? I've worked with many customers where, we'll turn on these brilliant detective controls or do some analysis and we'll go, oh, some of your users behave terribly and, they do this, this and this, and it's opening you up to all kinds of problems. But the business says, we don't mind. It's okay. We're not going to go out and try to change our culture, and therefore it's fine. Okay, that's their call. But do I still want my security analysts dealing with 30 alerts a day for this behavior? Well, no, because we know it's not good behavior, but somebody said we can't respond to it, so I'm going to turn it off. Maybe, maybe not. It's an interesting debate. So responsive controls, this could be into your incident management process, this could be for forensics, this could be all kinds of things. Now, the automation and orchestration component of this, automation being something that takes action without intervention, so i.e., I see a problem, I take an action, and the human maybe just gets told it's happened. That's also something that's automatic. Orchestration possibly being the same thing, but involves user interaction usually. So I'm saying, yes, go and block an IP on the firewall, and a script is doing it, orchestration, because the script's going and doing the action for me, but I've told it. Automation, the script gets automatically called and automatically blocks said bad actor. So hopefully that just gives you a really quick understanding of the types of capabilities within a SOC. This isn't all of them, and this isn't some standard. This is just a few bits and pieces I pulled together. So to do most of this stuff, a SOC, a security analysts, they need tools. They need tools to use, and these tools can look in many different shapes and sizes. But the one I'm going to talk about is a SIEM. So the precursors to SIEM were SIM or SEM, and a SIEM was essentially pulling it all together. I've put real time in brackets because, except a few edge cases, there's really no such thing as true real-time analytics, because I have to wait for an event or a metric to be generated. I have to wait for it to be sent to something that collects it. I have to then wait for that to be written to disk, usually, or stored in memory, and then need a CPU cycle to run some logic against it, and then I need to get an alert. Now, even with really quick compute, that could still be minutes, and that's usually the best kind of case you're looking at. Most of the stuff in AWS, for example, VPC flow logs, tons of their authentication events, you can have between 5 and 20 minutes of delay before you actually get the events of something that's occurred. And that's AWS. So when people talk about real time, they're really meaning as close to real time as possible. And you prioritize that based on, the value of the data. And then, this data could come from anywhere. Essentially, it just has to be machine readable. And it's going to get stored in some kind of big data tool. We use Splunk because it's what we're partners with and it's what we like. But, there's lots of things out there. It could be really basic in a database, but you need a way of both storing it and accessing it. So when I run a search and I look for something bad, I've got to run that search somewhere. And of course, the panacea and the best possible solution would essentially be a search engine like Google, but for my own machine data and security relevant data. So what SIEM's made up of? These are kind of 4 areas that I think are relevant to understand about SIEM. So the fundamental thing on the bottom is integration. So I want to be able to pull in as much data as possible from as many disparate log sources as possible. I want to be able to extend it out. So make sure I'm interacting with other tool sets. So, if my SOC uses Jira or ServiceNow or Excel to manage their tickets, I want to make sure that my SIEM can talk to it and update it and so on. We then move up to frameworks. Now, frameworks are really important so that we do things in a programmatic and repeatable way. So this could be where some of your processes are represented in code. This could also be where you do things like risk assessment. An example of that, when mixed with context, is if we have, let's say, a phishing campaign go out to all of our staff, and we have, let's say, 6% of people click on the link. Now, the SOC's going to get inundated, hopefully, with alerts that this activity happened. How do we start to prioritize it? Well, we need context, and that context starts with, well, who? Because there is a difference between perhaps a cleaner who just has an account to log in to update their rota to the chief financial officer. If both of them have malware on their machine, the impact that could have to your organization is night and day. They're both security events. They're both important, but one is something that you should be screaming about, and one is something that you probably deal with later on when it comes to a big incident. And so context within the SIEM, within something that enables to give you that understanding of criticality, that's really important. The other is, of course, asset. What machines are they? Okay, so this machine has no one logged in, but someone got a malware alert. Who owns it? Is it the CISO? Is it a contractor who's got no access to anything? Is it even our device, and how are we getting the logs from it? So, understanding what you've got and who should be on them, really important for context. And then finally, that analytics layer, that fundamentally, from a tooling perspective, is just the ability to query the data. Now, we obviously want it to be at scale. We want it to be able to deal with, terabytes, if not petabytes of data per day, and so on and so forth. But that's kind of out of scope of this talk. But, fundamentally, you want something that enables you to collect data, store it, and make it accessible to the end user, which is usually going to be a security analyst, threat hunter, etc. So before I kind of move on to the problem that some people face with this, are there any questions about kind of the basic foundations of SOC and SOC using SIEM? Because I realize that it's a lot to cover in a short period of time. So any initial questions on just the SOC and SIEM part? Cool. It's in here because I consider it kind of foundational knowledge to the next points I'm going to talk about. So hopefully it's given you a bit of a foundation. And if you already knew it, well, you've had your memory refreshed. So both the research and evidence from some of the customers I've worked with, though, is that the problem is that some SOCs are actually quite ineffective. True to false positive ratio, 1 to 110. This was based on some research done by Cloud Security Alliance. This essentially means that if you have that detective control, that rule in your SIEM, for example, and it tells you there is a threat, there is a problem, something bad has happened, it only turns out to be true bad 1 in 110 times. And that I've heard from people both locally and in London who've run their private SOCs inside their businesses have told me that that's actually a pretty good number. And I was like, oh, So I included the one that is actually research-based, but I've been told by many people that that's actually, oh, that's good, well done. Okay, if you say so. So what does that mean? Well, what that means is that you're probably getting quite a low value return. If that's the best ratio, or at least the average, that's quite low value. And I mean that in the sense of, if you're paying for, let's say, a team of 10 analysts, they've gone to great universities, obviously in Scotland, to get their ethical hacking degrees or their computer networking degrees and so on, and you've then employed them and trained them, and you've put them on SANS courses, and you've trained them in computer forensics. You've then sat them on a tool that's going to tell them when the bad happens so that they can do something about it, and they're sitting there, and 109 times they're going, false positive. It's not a problem. False positive. No, it's not a problem. False positive. It's not really a problem. How long do you think it is until that person is pretty much in auto false positive mode? Because humans are really good with patterns. We pick them up very quickly. And if we're going false positive, false positive, false positive, false positive. Dave, how's your weekend? False positive, false positive, false positive, false positive. Oh yeah, no, mine too, false positive. What was that? Oops. And these things happen. They've happened in SOCs we've run where you just get fatigue. You just get tired. You get tired of essentially being a help desk for IT, low-hanging fruit stuff that's very rarely has much value or impact to the organization. And it's not to say, you should just wipe out all those rules and that kind of work, because you don't want to miss that one, but you do want to try to minimize the 110. And we'll get to that in a little bit. So analyst fatigue, very closely tied into that, I think. I worked in a SOC. My background out of uni I was a senior security analyst, then moved into kind of incident management and security engineering. I'm now a consultant. And, I felt that I got RSI from copying and pasting screenshots into Excel, because at the time, it was a SOC that was up and coming, and thankfully they've moved away from that now. But, it was pretty basic work. And at the time, it was valuable to that individual customer and that business because we were doing compliance. But fortunately, SOCs have moved on now to less compliance focused and more threat focused, i.e. how can we actually reduce the risk of the organization or help them deal with breaches and threats and so on, be actual defenders. So anyway, analyst fatigue leads to complacency, it leads to possibly boredom. So the final one, and one that, we get told about a lot in the media and with InfoSec within our universities and schools, is there's a talent shortage. Not only of, individuals themselves, but individuals with the right skill sets for us to work with and bring into our organizations, defenders to train up. But when we get those people, and if we take into account the previous 2 points, how long is it until they move on? We put them on 10 grand SANS course. Amazing. They come back and they're like, I'm ready. I am so ready. But could you close down these 500 tickets first? How long is it until that individual goes, either I'm out, in which case all that investment's gone and you've lost a great person, or how long is it until they forget? Because, our brains do not remember things perfectly. We have to hone our skills. We have to practice them. It's why CTFs like the one tomorrow are so critical, because they keep things fresh, even if we're not necessarily doing it in our day job. So that is the problem, as I say, that is not the only problem in many SOCs and in industry, but this is, again, I'm just trying to get focused further and further down. So what's one thing that you can do to improve on this? And when I say improve on it, I mean, well, how do we improve our true to false positive ratio? How do we get less analyst fatigue? Well, we make the work more interesting and hopefully of better value to the organization. And this is about changing priorities, right? Reactive is when something occurs and someone usually screams at you, whether it's a computer or a human, and then you do something about it. Proactive is going out and looking for the problem in the first place, whether that's looking for a gap in your defenses, looking for a gap in your detective controls, i.e., but if we are breached, how would we know? And it's also about threat hunting and looking for the threats that are probably already there. And so I found this graphic on Google, as all good talks will, and I loved what it looks like, because although your security analysts hopefully don't have their feet up on the desk, they often are just waiting for the computer to tell them to do something. And that is relatively low value. When actually, on a night shift, low number of tickets, shouldn't they be empowered to go and experiment, to go and find threats that are out there, to put into place the master's course they've just finished, or the thing they've done on CBT Nuggets, or the Hack Yourself First course they've just learnt about, to go and actually look for problems? And that's certainly the argument I'm making. So let's say right now that we have agreed and we want to change priorities. Well, we now need to actually maybe come up with a bit of a methodology, because you don't just go, right, guys, start Googling for threats in your environment and look for stuff. Okay, I didn't find anything. Oh, okay. Try again. Didn't find anything again. Just keep going. You'll find something eventually. Okay. No. So we want a bit of a methodology. Enter OODA, which is my favorite word. It's not a word. So OODA, observe, orient, decide, act. As I mentioned earlier, this was coined first by, I think it was a general, but fundamentally this was fighter pilots in one of the world wars, which escaped me. And what they realized was that the fighter pilots were applying their training quite rigorously, quite sequentially, quite right. You do this, then you do this, then you do this. But as you probably guess, being a fighter pilot means things change quite quickly. Not only your orientation to the earth, but the missile or the guns that are hitting you, the fuel that's leaking, so on and so forth. It's a very, very fast-moving job when it's live. And so what they developed was OODA. They said, right, okay, just start. What's going on? I'm currently flying towards the ground. Okay, interesting. Orient yourself to it. I mean, well, how does that affect you and your plane? Probably going to die. Okay. What are you going to do? I'm probably going to pull up. Good call. When? Oh, shit. Yeah, should probably do it now. Yes, do it right now. So the interesting thing with something like OODA is it's irrelevant without the act. And again, in security incidents, when you're trying to contain a breach, when you're hunting for threats as a security analyst or threat hunter, etc., without the act part, all you've done is found a problem and talked about a possible solution or workaround. Until you act, have you actually delivered any real value to the business you're trying to protect? And so the reason I've kind of called out the detective and responsive elements, to put it in more kind of security context, is they're about detecting there's a problem and understanding its impact to you individually, as possibly an individual, or your business. And then the response is working out, well, what do we do about it? And then doing it. Now, I couldn't talk about OODA for defense without mentioning that attackers kind of cottoned onto this very early on. Because they use OODA all the time, as any pen tester, red teamer will tell you. OODA is essentially their entire life. Because what they're doing, and mapping that obviously to the kill chain, is always looking to gather information, changing their approach, seeing how it impacts them, changing their approach, seeing how it impacts them. Stu mentioned earlier on, he was almost caught 3 times. But he didn't just keep with the same story. And I know from him telling me more about that story, he didn't just wear the same coloured top. Guy in a red jumper is now wearing a blue jumper. Because people remember primary colours really easily. Because he changed. Because he went, I am under threat of being detected. I'm going to observe, orient myself to it. I'm going to make a decision. I'm going to go into the bathroom, new jumper on, and I'm out. And I'm no longer at risk, or less risk. So I'm not going to say this is a good thing necessarily, but it helps you understand how this is not like some magical new process or way of thinking. It is just simply a basic methodology to just remember that it's not just about, reading and getting a threat list of 20,000 bad hashes, but are they relevant to your business? Do you collect hashes? How are you going to compare them to anything? Useless. Can't. Oh, we can. Okay, that's useful. Okay, well, let's see what they come up with. Oh, we've got some bad systems. We've got some systems running software that was in that lookup. Okay, what are we going to do about it? Don't worry about it. Be fine. I think we probably need to do something about it. Okay, let's act, and so on and so forth. And attackers are doing the same thing. And this is, of course, now where we go, well, so we're familiar with OODA. Let's now apply threat hunting to it. And threat hunting is essentially OODA methodology, just zooming in a bit more. And the interesting thing with threat hunting is it's fundamentally the scientific methods. It's really straightforward in that context. You come up with an idea or hypothesis, and that could be based on experience. It could be based on gut feeling. It could be based on research, actual, hardcore research. You could have read a white paper, seen something at a conference, and then you go back to your environment and you go, they mentioned this thing, and it's really weird. They called it, I think it was Eternal Blue, and they said that loads of people actually had SMB version 1 still enabled on their perimeter firewalls. Couldn't possibly, we wouldn't have that, would we? You know what? I might check. I might see if I can do some research internally and figure out maybe we're vulnerable. You maybe speak to the network team and they go, oh, no, we've got WAFs, we've got IDS, IPS, we've got firewalls, next-gen firewalls, even better. Future-gen firewalls are around the corner, by the way. They're going to be incredible. And they go, oh, you know what, actually, we don't have any logs from our perimeter firewalls when it comes to configuration, i.e. is SMB1 enabled or not? Oh, could we get it? And this is where you're investigating, right? Tools and techniques. What tools you got? I have got SFTP. What technique are you going to use? I'm going to pull off the ASA configuration to find out what my perimeter firewalls are configured. Okay. Did you uncover anything? Okay. And now this is something that I will go into a little bit more, but you do not always uncover anything other than that you were wrong. Just like true science, right? People have published entire successful PhDs on saying, totally wrong, don't do it this way. Because that's the whole point. Your contribution isn't that you suddenly win a Nobel Prize for a major new discovery. Your contribution is, I took an approach, I validated that it was a good approach, but it turned out the approach does not lead to a cure for cancer. So, all the other cancer researchers in the future don't do that. That is valuable, and that is a PhD. Great, well done. And it's the same in threat hunting. Your outcome, your uncovering of something could be to uncover that you are completely wrong. And that is still valuable and should also still be considered to be rewarded. You shouldn't grade your threat hunters on the amount of threats they find. You should grade them on their rigor of their documentation, their approach, and that they learn, because this is a cycle. And so that inform and enrich is exactly that. You've got to actually take the information you uncover and put it back into something, into a system of some form. It could be OneNote, it could be Evernote, it could be a dedicated threat hunting platform, or it could be Jira, don't care, but it's got to go somewhere. And then as part of your process, when you're creating your hypothesis, you review results of previous attempts, right? You look at the data, you do a really quick lit review essentially, and then you proceed. And then, of course, the thing that we're actually trying to do is disrupt. Because if we've got an active attack, we want to stop them taking their actions on their objectives, exfiltrating data, destroying our network, etc. So just to kind of frame it in a slightly different way, we're trying to essentially figure out new ways to either discover that threats are on our network or disrupt them. And they are trying to figure out how to get around any of those detections and make it so you can't disrupt them. And this is a cat and mouse game that we all play every day in different ways, but it's especially important when you're thinking about threat hunting, because as soon as you put in a new use case, a new detective control, your attacker goes, oh, you detective control over there. Right, let's do some proof of concept stuff. Okay, let's pull, they've published their code and rules on GitHub. That was nice of them. So let's apply them in our test environment and work out our way around them. You know, there's a reason. Well, there's multiple reasons, but one of the reasons that, Windows for such a long time had such a bad rep for being attacked by malware is because it was the market leader by like 97%. So who am I going to attack? I'm not going to attack Apple devices. I'm not going to get anyone. I'm going to attack Windows devices because they're everywhere. And so, don't argue with me about security of their platforms because we'll be here forever. But the point being, they're going to go and they're going to modify it. They're going to iterate just like we would. And I found this actually late last night, which is one of the slides I added, so don't ask me to explain all of it. But if you've got your OODA cycle, which is the bottom right, which is your hunting, so to speak, the interaction and the integration of this, of other parts of your security posture, your security team, become critical. This isn't a thing to do in isolation. Your response over there, right, is fundamentally you trying to stop bad from continuing to happen and you to recover from it. And then, of course, your intelligence is, well, how do we enrich other things? So if I find something that's bad or maybe potentially bad, do I just keep it in isolation that I only apply to my searches and my controls? No, I share it with the team. If we're part of a larger entity, maybe we share it with FS ISAC, etc., and try and get it out to the community. Maybe you do a talk on it, whatever. But, you should share it. And something when you start to look at the breadth, so to speak, of this, you also realize that this isn't novel. This isn't particularly new. Security people around the world doing things like threat hunting shouldn't be going, we're using Agile in a way now, and as soon as we find something, we create a change ticket, and it's great, and we've got a life cycle. And you're going like, pretty sure developers have been doing that for a while. They just call it something else. And again, this is a busy diagram, and you can blame Gartner for that. But this is all about just embedding security within your development operations. And I'm not going to get into AppSec or app development here, because this can actually be applied to security operations centers. Because every time you find bad, you should be trying to change something, right? If I find that there is malware on all of our endpoints, well, that means that controls all over my estate have failed. Was it the security awareness control? Did they not complete their training? Was our training crap? Is our AV not next gen enough? And we need more of the next gen in our AV to stop it coming onto their endpoint? Do we need better WAFs, better things, so on and so forth? So the SOC should always be trying to inflect change within the organization, but also internally. And that's what we're going to get to next. So for the sake of argument, we've been on some successful hunts, and we have detected an advanced persistent threat on our network, and we've managed to get them out. We cleared them out because we're amazing at what we do, and our organization supports us 100%. We go, well, we've just uncovered like 5 new ways that they got in. Okay, awesome. So we've maybe made change tickets, and we've told people, you're going to need to invest in this new type of technology or whatever. Okay, and they go away and do those projects. But in the meantime, well, you don't just want to have to repetitively hunt for the same thing. That's what computers are good at doing, right? And this is where your SIEM comes on board. So you're going to say, well, I was able to detect this APT via the following log sources, hashes, TTPs, right? And I'm going to create a new use case. And the use case, generically speaking, is just a way of using a thing. And in this context, it's creating a new rule, correlation, baseline, etc. Okay? So if you stay with me, we're in a SOC. We've found bad, and we've figured out how to detect it. So we want to detect it if it ever happens again, because all the controls are still the same as they were when it got in the first time, because the project's not finished up yet. Okay. So I go into my SIEM, go into my tooling, and I go, I want to edit this rule, and I edit the rule, and I save it. Not in any enterprise, because you need change control. Because what if you change it wrong? You could take out all of our detection, and we've got like 1,000 rules. Oh, sorry. So I can't do that. So what have I got to do? Oh, okay, so we need a change ticket. Okay, done that. We need to deploy it into dev. Okay. You need to generate some dev data, validate it. It works. Amazing. Okay, we're now 2 days, 3 days in. Okay, awesome. I want to push this into pre-production to test it at scale. Test it in a like production environment. Okay, cool. The next window is March. Okay, that's fine. That's 3 weeks away. We can wait 3 weeks. Okay. So now in pre-production, test it. Works. Good job, because you used dev properly. And you now want to push into production. But the problem is, last time things got pushed to production, it actually took out the wrong rule. They added a 0, and instead of looking for 10 failed logins followed by a successful login, they looked for 100. So it never triggered. So now it has to be signed off by a senior manager who will validate your logic before it goes in. And they're on holiday for 2 weeks. And you can't even get the change record approved until they 4i it and check it. Okay. Wait for them to come back. They check it. They say, good work. You did a great job. You get your change window, and it's pushed in. Amazing. You now have all the way from the, the results of your hunt, new detective controls in production. But how long did that take? In many organizations, especially ones that are heavily regulated, and heavily regulated for good reason, that could be a month. And for that entire month, are you manually running your hunt every day just to make sure that APT's not come back? Probably not. Are you hoping they didn't come back? Doesn't sound like a great idea. And this is where change comes in. And this is where what I would call, either your change stack or change as code becomes really important. Because what you have to do to get support to change systems more frequently is you have to show them how safe it is to change it. And you do that by connecting things like your change system, your change record, your tickets, with your actual source code, your configuration. So this is an example pulled from something that we did. And we use, these tools, so we used Ansible as a configuration management tool. So this is a thing that looks at files and says, I'm going to do this in this order for you. It's great. We use it for hardening boxes, for example. And every hour it will log into a Linux server and say, are you still security hardened against the CIS benchmark for CentOS 6? And it will go, yes, I am. Okay, just checking. Or if it finds out that it's no longer hardened because maybe someone pushed some code that changed some configuration, some SE Linux settings, whatever, it will go, hold on, I told you, you need to have SE Linux enabled with the following policy. Oh, sorry, changed it, thank you. So it's an automation and orchestration engine. Docker is a containerization tool. In this example, we didn't really use it correctly. We essentially used it as really lightweight and transferable VMs because we weren't actually building code. But anyway, we used it to great effect. And we used GitLab for version control. Version control, if you've ever used Microsoft Word, is track changes on steroids, and it's great. So this is how we used it and this is bringing our SIEM under all of this. I should probably have opened with that. So if you set up a tool supported by all of this technology, now I can see programmatically exactly what's changing, where, and I can roll it back in seconds, as opposed to incredible long change windows, backout plans, massive backups that have to be taken first because it's so dangerous and don't touch it, it might fall over. This way, I think we got to a change from dev to production with still approvals, but once the approval was ticked, it was 20 minutes, straight through. Some automated testing. It was great. So the SOC were able to put a new rule into production really quickly. And so identifiable environment, so dev, pre-prod, production, all the same, all kept in check. We eliminated fear-driven development. So some of our security analysts were really quite worried about, making changes, of course, because we had somebody in that example of adding a 0 to the amount of login fields. It's not a good day, but anyway, happens. So, but this way, it's okay to make mistakes, because if you make a mistake, you just roll it back. And the system itself makes somebody else check your code quickly. It can be a peer, but you've got that peer check. This meant that, so we took away everyone's access to production back end, so no one could edit anything in production, full stop, not even the admins. There was no way except with a break glass account to log in to pre-prod or production servers. We took away everyone's SSH keys one day, and they were like, what? I'm like, well, yep, Ansible should be doing it. So Ansible's keys were the only ones on those servers, and you had to make your changes in dev, commit it into version control, and then it would do it for you. And by essentially removing the option of manual changes, it essentially protected the system, but also got people into the workflow that we were trying to put in place. Mon means a disaster recovery, so infrastructure as code. So this was all built in AWS, for example, and we could just get Ansible to rebuild it. I mean, you might lose the data, but all the configuration, all the rules, all the access controls, everything, the hardening of the servers, we could literally clone the whole thing just build it from scratch, like for like, just missing the data. It's really cool. And security driven, so this was more about keys, so I'm not going to deep dive about that. But so all of our source code was on GitLab. Interesting thing about source code, they love credentials because they need to do things in an authenticated way. And so we had to store a ton of secrets. Like, you don't want to store plain text secrets in any kind of version control because it's there forever in your history. And plain text, very naughty. But at the same time, if we encrypt it, how do we get the system to automatically decrypt it? And Ansible has got a great free tool for this called Ansible Vault. So we essentially have Ansible encode and encrypt the data before it's written into Git, and then Ansible decrypts it at deploy, so the code stays the same. It was really cool when we kind of used it, and we're like, we have absolutely no secrets in plain text anywhere. Really cool. It looked like this. So top line, our dev environment, all built in containers. So an individual engineer like myself could pull down the code base, say run it dev. It would spin up 5 Dockerized containers, and my SIEM clustered and built and everything was there with my production configuration. Not production data, but production configuration, completely like for like. Because we could only promote up from dev to pre-prod to prod. You couldn't promote background, right? Again, by stopping that, you stop getting out of sync and out of control. It made sure that dev, pre-prod, and prod were always identical unless you were making a change. But your change had to start at dev, be pushed into pre-production, and then pushed into production. So that's what it looked like in dev. Pre-production, much simpler because we don't use containers. We don't have to kind of bootstrap some stuff. But you'll notice that the first step for pre-production and production, hardening. Are you still secure for me to actually publish code to you in the first place? I'm totally still secure. Okay, then. It's allowed. Okay, I'm maybe not that secure. Well, no code for you, unless you get hardened again. And that's how it worked. So this was just really interesting for us. So we're not a kind of, a dev house at all. We don't typically do product development. We don't really have any developers. This was just done by me and some engineers. And we kind of, really didn't know much about DevOps either. We used Agile in some of our projects, but DevOps itself and some of the tooling, it was really new for us. And so being able to kind of pull this together, and bear in mind, I'm linking all this way back up to the SOC, to the hunter wanting to actually push something in, and so on and so on and so on. I realize it's a long journey we've been on. This was the kind of the end point of the project and what worked. This wasn't perfect. We still had some kind of bugs at the end that we wanted to fix and improve upon, but it did mean a massive change to the way that we ran that particular SOC. Because again, rather than it taking weeks and weeks and weeks, and that was in a really pretty small SOC, small organization where they'd approve things quickly, it still took weeks to get code into production. Whereas this way, we could show the track record, all source controlled, and you know what, if you made a mistake, that commit, that made the mistake, that's got the extra 0 in it. Okay, let's fix it. 20 minutes, fixed, done. But it's not just been hot fixed. You've not just logged into production. Oh, just SSH in and change that in case no one noticed. That's fine. You have to go through. You've got to be approved. But then it's programmatically distributed. So bringing it all back to the SOC, and this is my last slide-ish. It's a bit markety, but I just really like pretty pictures. So the idea being that your SOC has moved from this place of quite a lot of inefficiency, those analyst fatigue and so on, but instead you're actually kind of moving away from that and you're moving into the hunting space, looking for control gaps, either in your prevention, detection, or response, and then actually being given the tools to make those changes yourself. Not in all cases, but ideally in some. SOAR, which is down there, which I've not really mentioned and I'm not going to, other than to say that security orchestration, automation, and response. It's a relatively new area of technology where it's trying to essentially make it really easy for you to make changes, not in the SOC, but outside the SOC. So automatically blacklisting IPs when you see them bad, automatically taking actions within your environment or pulling in virus total information, that kind of thing. The couple of final things on that is fail fast and fail safe. Some very interesting concepts that I just learnt about when going through this process. Very much failing fast means if you're making changes quickly, then you know what failed quickly. If you do one big blowout at the end of a 6-month project and you deploy 1,000 changes and it doesn't work, you're having a terrible, terrible Christmas. it happens. Never do a big production change before Christmas. You're guaranteed to ruin your day. And fail safe, because with your route to live, well, it failed in pre-prod. Perfect. That's exactly what, good. It should have failed in dev, because dev should be as like for like as possible. But hey, pre-prod's there to do that, to stress test, etc. And then the other one was just make everyone a creator. It sounds a little bit wanky, but when it comes to a SOC, again, people are often seen as essentially security help desk technicians, and that's not what they are. It's not what they've trained to be. What they've trained to be is problem solvers, and ideally, defenders, people that understand elements of their domain, and they try to use those skills to better your organization. So give them tools that equip them to actually go and help your organization. So that's reducing its risk, identifying threats, and overall, hopefully, protecting you from things like, the beer farmers were talking about, that Stu was talking about, actually reducing the likelihood of things like breaches of, ransomware attacks and so on. And that's me. So just quickly, and QR Code Central, I co-run Cyber Scotland Connect, which is a community-based organisation in Scotland, out of Edinburgh, because where I live. I co-run this with Stu Hurst, of much fame, so you may or may not have heard of him. We run meetups, so we run 2 meetups in Edinburgh. One is like the big one, and it's like 140 people, usually with some great presenters, great speakers. And we also run the little one, which is open mics with no singing, because we can't sing. But the open mics are essentially you do not have to prepare a talk. You don't have to get permission to give your talk, with some light boundaries, obviously, in good taste and so on. But you can just stand up and talk. And so, we run that every other month at Napier. And yeah, it's been really successful so far. People literally just to rock up and go, right, so I work in a SOC, but I'm going to talk about physical security. Got no background in it, but I've been learning about it. I thought it was really interesting. Like, oh, that's really cool. Another guy stood up and said, I'm a threat modeler. Does anyone know what that is? No, cool. And he went for 20 minutes talking about threat modeling. It was fantastic. And so the idea is just trying to encourage people that are perhaps less experienced or less confident. It's very non-judgmental, so please do come along. You can find us on Twitter, LinkedIn. We've got a Slack. It's the same Slack as this event's using. And we've started collating resources that we think are useful for the community. And what's really interesting is in the few commits to that we've had so far, the vast majority of them have been nothing to do with technology and everything to do with inclusivity, equality, well-being, mental health. It's really interesting just to see like the spread already is people going, how can we support each other better, be kinder to each other, etc., i.e. don't be dicks, as everyone else has said so far. And so yeah, that's it. And any questions? Hello.
Yes, very interesting. I work in industry and actually started using Docker, all those tools.
Yeah.
I'm really interested to understand or to hear from you your experience with the use of anomaly detection, machine learning, or detection of UTP plans.
Sure. So within kind of the SIEM space, and
Can you repeat the question?
sorry, yeah. So the question was, the use of things like machine learning for anomaly detection, behavioral insights, that kind of thing. And so I've used that personally in 2 tool sets. So that the first, which is an extension to the SIEM really, and that is so with the tool that we use, Splunk, you can install a thing called the Machine Learning Toolkit, and that's essentially all the open source Python libraries that you can do a ton of machine learning with. And it can be really useful at giving you indicators. Now, I've not seen much success in it having like 100%, I think the marketing is very biased when it comes to AI/ML. And it's, always go from 1 billion events to 100,000 alerts to just finding that one guy. And it's kind of like, yeah, sometimes. And sometimes you go, that guy's not worked here for a year. Shut up. And so I think it's not, It's not all it's cracked up to be, but it's another tool. It's another way of looking at data in perhaps a less deterministic fashion, and to look for things like, so the most effective ways I've seen it used is basics around peer grouping. So that's when you say, so you five are all admins and your behavior is this, and you spend this long online per day, you log in this many times, your average failure rate for your logging into your password is this, and you log into these servers roughly once a week. Cool. This person is a developer, and and part of their development group, they on average only log into their own box and their jump box for deployments. And suddenly that guy's logging into 100 servers within the last 5 minutes. That's weird, but they're not brute forcing. They're all official. They're all good logins. So, all your detective controls or your normal alerts wouldn't pick that up because that's legit. But machine learning might, if you do things like peer grouping and behavioral analytics, might go, but wait a minute. His peer, the people that he communicates with, that he's in the same group of, same line manager possibly, they never do anything like that. That's the kind of activity that someone like that might do. That's odd. Now, it's not proven malicious. Maybe he changed job role. Could be. Or maybe, someone's hijacked their account, cracked the local admin password that the admins use and is now all over your network. So that's where I've seen the actual genuinely finding threats or indicating that there are threats. Any more questions? Any questions outside of the topic? Don't mind answering anything else. That's fine. Awesome. Okay, guys. Thanks a lot.